All right. Well, we're going to get the presentation underway. Thank you, everyone, for joining us today. We're lucky enough to have Kirk Harnack, who you see on This Week in Radio Tech, and also with the Telos Alliance, and he'll tell us more about what he does. But today he's going to speak about containerized software, which I learned about when I went to the NAB and we had a PBS gathering. And that was the first time I started hearing, oh, this is really gaining traction. There's so much that broadcasters are doing virtually today. So I thought it was very fitting that we bring it to both chapters. And with that, I'd like to throw the floor over to Kirk. And thank you very much for joining us.
Thank you, Mike. That's a nice introduction. I really appreciate it. Hey, just to follow up on some of the things that you were talking about before we get started with this, I discovered something pretty interesting about our EAS CAPS service. We had two of our radio stations, one in Oxford, Mississippi, and one in Lihue, Hawaii, that the CAPS function in our SAGE systems wasn't working. And if we would, working with SAGE as you know, troubleshooting, we discovered, and it was rather cryptic to discover, but because we were getting an error, if we just used a browser to go to the CAPS server site, we were getting a very long string error message. And it turned out that our fixed IP addresses at both of these sites were being actively blocked by Akamai, who apparently is in charge of the firewalling service, at least for this portion of it, at AWS. And AWS is where the iPause services that we were connecting to is located. Anyway, and so I've scratched my head thinking,
it's highly
man,
confusing.
Yeah, what are we going to do about this? We're blocked. And it just so happened that I was traveling to the Alabama Broadcasters Association, and they Sorry? Can you hear me okay?
Yeah, sorry, I muted Hal. He may not have intentionally spoken up.
Okay. So at the ABA meeting, I happened to ask, and an IT guy there said, "Oh, you're screwed. You'll never get off that list." I said, okay. So I continued with my efforts to have the providers at each location, two different providers, change my static IP address. Well, that never went forward because somebody said, you can call support at iPause, and they will probably be able to do something about this. So I looked it up and I found the support number for iPause, and I called late one night because that's when I was available to do so. Got hold of a nice lady, and she seemed to actually understand the problem. And that started an email thread. Within 24 hours, both sites were clear, and it worked fine. And I just it was way better service than I expected from a government or government contractor support department, that they were able to solve this, especially when the IT guy in Alabama said, "You're screwed. You'll never get off that list." So wow. There you go. All right. Hey, well, welcome in. We're going to talk about, for about 7 or 8 years now, I've been crowing about the possibility of virtualizing broadcast operations. I mean, so many other things in our life are virtualized, and well, would it make sense to broadcast some broadcast operations, maybe eventually all of them? I mean, I've always had this dream of, hey, what if I could spin up a radio station in the cloud that had access, that behaved just like the stuff at my radio station does. I could do voice tracking. I could bring in live programs. I could bring in CBS News top of the hour live. Now I realize they don't have a satellite receiver. They don't have an XDS or an iPump Wegner receiver at AWS places. But what if there's a way to get that there? What if I could do all my music scheduling and my traffic log and all that in the cloud, and pay a monthly fee just to have that done, and then squirt that audio out either by codec or by, let's say, micro MPX format to go to a transmitter site? Would that be interesting? Would that be worthwhile? Would that be a good disaster recovery plan? Would that be a good everyday plan? I mean, I can't tell you how long it's been since I've seen a bank teller in person. Because I do all my banking online. I go see my bank teller just because I like them. I think they're pretty cool people over there. But anyway, so I've been crowing about this for 8 years, and finally, we have enough product out there in the marketplace to make some of this happen. Now, there are you can contract with some companies online in the cloud that let you build a web radio station. And it has some of the things that a broadcaster needs, but very definitely not all the things. So anyway, as we jump into this, there's just a little list of the things that I do. Thank goodness none of these things take up a whole lot of my time. Mostly the things that Telos Alliance do, but I'm also involved with some radio stations and groups. Delta Radio, South Seas Broadcasting in Hawaii. I'm sorry, South Seas Broadcasting is in American Samoa. Kauai Broadcast Partners in Lahui, Hawaii. Oxford Media Group, we just built our first stations there. And Akamai Broadcasting, we just got FCC approval 2 days ago to purchase 6 licenses on Maui. So we'll be doing that. Now, so my point is here, now there's real world examples of doing the stuff. And I know a lot of times I refer to cloud, but cloud isn't where it's at for everybody. In fact, for most people, that's not where it's at. It's putting virtualized broadcast infrastructure in your own facility. And this control room has a pretty interesting story that we'll tell a little bit later in the presentation. This is WBZK-FM and HD, plus HD2 and HD3 in Oxford, Mississippi. It's licensed to Taylor, Mississippi, but it serves the Ole Miss crowd with an alt rock format. This is the control room. That's Chris Green, our morning guy. There, and I'll explain it more later, but the only thing in the control room are 3 mics, 3 headphones, a little virtual mixing console, although it doesn't have to be virtual. It could be it could be anybody's little console, and then computers to remotely access the automation, the phone lines, the audio mixer. Basically, all the infrastructure is at the transmitter site because that's the way we had to do it. Basically, the reason is there were no appurtenances allowed on this rented office building. Nothing, not even a tiny little IP radio antenna. Nothing on the building. So we put everything at the transmitter site, and we do by IP. We do a 4.5 hour remote every morning from this studio, but more on that later. My inspiration for this was a station in Alva, Oklahoma, KZLF, where a couple of dudes there own this radio station, but they're IT people. They own a small data center in that area, and so they put most of their infrastructure at the data center. On the right, KZOZ-FM. This is a mixing console or access to one, and this is in the kitchen of half of the morning crew. And he had to move. His wife got they were in San Luis Obispo, California, a morning team that had been together for 17 years. And half the morning team, his wife got this awesome job in Washington State. And so they had to move almost 1,000 miles. And the decision was going to be, do we break up the morning team or do we continue rocking on KZOZ? And the guy that was moving, he's the guy that ran the board. He was a smart guy. The other guy was like the giggle chick, but he was a guy. So anyway, they were doing this at the same time that my employer, Telos Alliance, was getting this technology ready to go. This is Jason Aldean's kitchen and rooftop bar. And on the left there is Jason Aldean cutting the ribbon for his location in Gatlinburg, Tennessee. And on the right is a little picture of the studio, the virtual studio inside at Gatlinburg. Well, the console is virtualized. The studio's actually there. So we're going to hear from the engineer that put that together in a few minutes. Now, actually, I was last night, my wife and I and her daughter and niece went downtown Nashville. We went honky-tonkin' for a little while. And there's a Jason Aldean's in Nashville. It has a radio studio. But that is a bona fide hardware, by golly, we spent a lot of money radio studio. It's there owned by iHeart, and it does not use Telos Alliance gear in there, but it looks to me like a $30,000, $40,000, $50,000 studio. It's nice. The one at Jason Aldean's in Gatlinburg is kind of virtualized. There's not a lot of gear in there, but they have access to everything at the radio station, which is back in Knoxville, Tennessee, an hour and 15-minute drive away. Well, containerized software, it looks to be where the future of computing services is at. This is a little bit different than virtual machines. Microservices and containers are apparently the industry future trend for software. And companies like Google, Amazon, Visa, PayPal, MetLife are all using containerized software. About 2 years ago, I was at a mini golf with my son and my then girlfriend, now wife, Carmen, and playing right behind us was a foursome, and a gentleman was in there about my age, and I asked him what he did, and he said, "Well, he's the CTO for a healthcare company. He runs a data center in Murfreesboro, Tennessee." And I said, "You guys using any of these software containers, or are you using virtual machines? And what's your infrastructure?" He says, "Oh, everything we have is containerized. It's all Docker containers." So, "You don't have any virtual machines?" He says, "I think I got one on my laptop, but I don't use it just to test stuff." So yeah, everything they do is done by container software, or Docker technology was the company that came out with that. So what is containerized software? Well, my colleague here, Jake Alderman, will speak to that.
Containerized software is a new method for deploying software in a more lightweight manner. So traditionally we had applications that installed onto an operating system and would run on your desktop computer or a server. And we're all used to those in the broadcast environment now. And in the last 10 years or so, we've started to see some people use virtual machines, and that's taking a physical piece of hardware and making a virtual version of the computer, installing the operating system, and then installing the application on top of that operating system. Containers are a middle ground between those two. What we're able to do is, instead of virtualizing the whole machine, we're able to create an isolated place to just install the software we need, like an audio console or a phone system. And so what we do instead is we share the operating system, but we have this isolated bucket so our audio console doesn't touch anything else. And it's not actually called a bucket, it's called a container. So you've got your container that holds your one application in isolation, similar to a VM or a physical computer, but it's able to share the resources of that greater compute platform.
So graphically, this is what it looks like. At the bottom there is a server, typically a server platform. On top of that goes the host operating system, and that's typically going to be some flavor of Linux. On top of that goes the Docker runtime engine, which services the needs of the containers. And so the containers have just enough code in them to do what they have to do, kind of like the program, the application, and any libraries that are needed that aren't likely to be in the host operating system. So here I've just made an example of, you can put a Telos VXS, that's a phone system container in there, Infinity VIP, that's an intercom system, and maybe a couple of Axia Altus audio consoles. Typically, these applications take about one CPU core per application. Some take more than one CPU core, but those Axia Altus mixing consoles, even if you turn on all the mic processing and all the auto mix and everything, it just takes up one core. So you can fit a lot of stuff onto one physical bare metal server. Audio over IP, let's just review that for a sec, just in case you don't have that in your place yet. It begins with the IP network. And by the way, it's audio over IP that makes all this possible, because servers don't come with XLR connectors or SDI or BNC connectors or anything like that. We have to do everything over IP. And when AOIP was invented, separately by us and by the folks at Audinate in Australia, I don't think anybody really thought of doing all this work in servers. We were just trying to move audio around in a way that was fully compliant with standard networking. Now we do put to use, whether it's Livewire or AES67 or Dante or WheatNet or Ravenna, any of these audio over IPs, they all work really very similarly, just not a whole lot of difference in them. And they use the standard protocols that are built into the better Ethernet switches and Ethernet networking. So in a typical system, you've got a core Ethernet switch that everything goes through, that keeps track of all the streams. And then you've got input-output devices. Here I'm showing the backside of several Axia X nodes for audio inputs and outputs. And then you might have, for example, a PC. And if you take a PC, which has all this information in it, and audio and title and artist and all that stuff, you put a separate network card in there and you install an IP audio driver, which makes the Windows or Linux think that there's another sound card there. Of course, any sound card, even a hardware sound card, is going to be running a driver, so that's no different to the operating system, whether it's a real piece of hardware or whether it's an Ethernet card. So that PC is going to connect directly to the network and provide audio in and out of the PC without using a physical sound card. Then we can attach other things to the network. We can attach a mixing engine, like in the lower left there, and then to control the mixing engine, we're going to use something that looks like an audio console. In our case, think of it as a computer mouse that looks like an audio console. And the console tells the engine, hey, subscribe to microphones 1, 2, and 3, and subscribe to the network feed, and subscribe to the automation output, and mix those things together at these levels, as you indicate by the position of the faders, and then give me a new output called program 1 or program 2 or control room monitors. And so that's what the mix engine does. It does all that under the direction of the audio console. In our case, there's no audio in the audio console itself. All the audio is in the mixing engine, being told what to do. Once you have all that set up, you can add other consoles to the network. Here is a small console called the IQX that happens to have the mixing engine bolted onto the bottom of it. So it's a complete setup. One cable to the core switch, and you've got access to anything that's on the network, plus you might want to put something locally. So there's another Ethernet port on the bottom of this console that you can plug in something like another X node and have a local microphone. So the point is that you can see that in an audio over IP world, you quit being console centric and you start being network centric. And for 100 years in radio, we've been very console centric, right? Everything has to go through the console. We think about the console as the center of everything. And in our world, even though my employer, Telos, makes a lot of audio consoles, it's no longer the center of the world anymore. It's the Cisco switch that you have to buy that becomes kind of the center of everything. All right, well, on with the examples here. What if we said, let's get rid of that hardware audio console and let's control the audio mixing engine with something else. Let's control it with a piece of software, like on a tablet. Or here's actually third-party software. This is made by a company in France that makes very flexible, very customizable user interfaces. And so that's another possibility. Or even use some existing software that Telos makes called Pathfinder. You can build a little simple audio console with it. Point is, you don't need a piece of hardware to control the activity of the mixing engine. You can use other things. Well, so we're going to use other things. And in fact, in this example, we've replaced that hardware mixing engine with a picture that looks like what we had before. A server, host operating system, the Docker engine, and then how about in this example, 6 audio mixers or mixing software done in software containers. So there's 6 consoles in there. Each of them not only mixes audio, but each of them has a web server. So that means you can use a browser anywhere on the network or even outside the network, as long as you have remote access. You just browse to it. Your browser shows you the equivalent of an audio console, and then you can move faders up and down and turn buttons on and off. And if you have a touch screen, you can use the touch screen to do those things. If you don't, you can use your mouse and pointer to do those things. And earlier, remember I said there's no audio in the audio console. Well, same thing here. There's no audio, at least there's no live wire audio in the mixer that's in your browser. So that means you don't need to be on the same LAN. You can be, but you could also be remote. So through the internet, or through Wi-Fi or other things that won't carry audio over IP or won't do it very well, we can still have control of that software, that Docker, that software container audio mixer back at the radio station where all the sources and the destinations are. So we can control that on the network or remotely. We also, I'm not sure if I explained this later, so I'll explain it now. We also thought, well, if you're remote or even if you're local, you're going to need to hear what you're doing, and maybe you're going to need to contribute audio, like with your own microphone. So that's why I put the white icons there with the mic and headphones. Well, guess what? Every browser built since about 2017 has WebRTC built in, and I'm not sure if Zoom uses WebRTC or if they've modified it to their own purposes, but if you do a Google Meet, you're using WebRTC to handle the video and the audio. So the codecs now are built into the browser, the Opus codec, and I think a couple others. So we can remotely have audio contribution and listening. It can be done at a high bit rate or a very low bit rate, whatever is available to you. And so you've got that audio. Remember the picture I showed you at first of Chris Green in the control room in Oxford, Mississippi. Every show he does is a 4.5 hour remote, and his audio gets there by WebRTC, and he hears the station back by WebRTC. And since we're HD, he can't listen off the air, and, so 8-second delay. All right, moving on. Oh, here's Chris Green to talk about doing this with virtual gear. Chris is no engineer. You'll get that from listening to him, but he is a good on-air talent.
Man, it's so cool. When we got into it, I was like, I feel like I'm in the future right now because I've only used traditional boards with sliders and faders and buttons. And initially I was like, man, am I going to miss that? But as soon as you use Axia Altus for a little bit, you start realizing how responsive the touch screen is. I mean, sometimes when you're about to jump on the air and you need to hit, your fader up, instantaneous. I mean, you get amazing reaction time with just a slight twitch of your fingers. And it has been, the transition was quick. And I can't imagine going back to a traditional mixer board.
Okay. So let's have a look at some of the operational features. See, if you design a console in software, there's some things that you can do, and there's things you can leave out, and there's also things that you can have appear only when they need to. So if you build a hardware console, you've got to put a button there that may never get used. I used to do TV weather, and I'd walk into the audio room at the TV station at Fox 17 in Nashville, and there would be this huge audio console, and you could see the parts of it that they never touched because they were covered in dust. And the things that they touched were pretty much just the mixers, and once in a while some backfeed, some aux bus control. But everything else had dust all over it, and you could tell 80% of the board they never used. Well, with a virtual console, here, let's just go through that. There's obviously the program mix meters at the top, but you have context-sensitive buttons. Fancy way of saying, let's not show you buttons you don't need. So that's the mic input right there. And so you have a talkback button and a pre-fader button and an options button. But a lot of and here you've got some drop down for source selection, so you can change what's on a fader. But you'll see plenty of those faders don't have a talkback button because you can't talk that. Look at the playout over toward the right there. You don't talk back to the playout system. You may want to, but you can't talk back to the computer. Same thing for the hotkeys and the fader next to it. There's no talkback there. Because it's a software console, it costs exactly zero money to put some code in there to give you pre-fader metering or confidence metering of what's coming into a given fader. We don't have to buy LEDs to put there. It's free. The channel slider. One thing we figured out in designing a slider for this was we could have put a knob there that you had to target the knob with your finger or your mouse cursor and click on it and move it up and down. But, well, why make you target something? How about just be able to touch anywhere in the slider channel and then, touch and drag it up and down? And so you can do that. You don't have to target where the knob should be. You can, but you can also touch anywhere and slide up and down. Phone control. We can have that pop up if you have a show that takes phone calls. Well, that show has the phone fader in there, and that show also has the line control buttons. We can have that on there, or if you have a show where you don't take phone calls, we can not have that on there. Golly, what else here? Come on, let's go for it. Oh, there we go. Yeah, there's those context sensitive buttons right there. In this case, you touch options and you get things like the input gain and the balance. You can also get EQ control, or you can keep the jock from having access to this also. And then you also have dynamics control for the threshold and the depth, the gate for the noise gate, compressor, and the de-esser. You have those access to those controls. All right. So if you have a virtual console, there's a lot of things you can do. Full function mixing, as I might say. The control is all within a browser. You don't have to install anything. In fact, usually when I demo this, I pull out literally a $250 Chromebook that has a touchscreen, and I can control the radio station with that, and contribute audio and listen to audio on the same Chromebook. There's some other things that are you can have 8 simultaneous users of this. You can have people in different cities or just different rooms with access to the console. It's good for deploying temporary studios. You can also use a computer you already have. You don't have to buy a computer to do this. Just run a browser, and you can do it on a tablet. You can do it on a phone, but it's a little small. I mean, we resize it automatically, but it does get kind of small on a phone. Takes up no additional space. And it's good for disaster recovery too. Okay, I mentioned this guy for the stations at Jason Aldean's kitchen in Gatlinburg. This is Jeff McGinley. You may know his father. His father is Tom McGinley, and Tom's been an outspoken engineer for decades. And Tom's been I don't know if he still is, but he's been the technical editor for Radio World magazine. Anyway, this is his son Jeff, and he's talking about people getting used to touchscreens.
It took the morning show about half a shift on one of the stations. The afternoon shows took about 5 minutes. They're, they took to it really quick. They were very appreciative of the Livewire upgrade for everything else. There had been it had been kind of an older facility, and so there were some nagging issues that were going along with the older technology. So we were able to not only give them new stuff that they really enjoy, but we were also able to fix a number of other things that they've just learned to live with over the years. So no pushback whatsoever. They were extremely happy about it.
One of the things that I've sure noticed when I talk to people about as part of virtualization, if you want to do a touchscreen console, right? You don't have to, but if you want to. Well, the usual response I get from engineers is, "Oh, we got some really old disc jockeys, and they ain't gonna like that. They got to have buttons and knobs." Well, really, how do you know that? So what Jeff did, Jeff did give him a choice. His first experience with this was actually in Portland, Oregon. He used to be the director of engineering for Odyssey in Portland, Oregon. And like everybody else in Portland, they actually became homeless for 7 months. Their whole radio station had no place to live. They had no studios, no offices. They rented some temporary office space, and a lot of people worked out of their homes. Of course, they had the transmitter sites, and they ended up putting all this infrastructure, all this Telos Axia stuff at the transmitter sites. And the jocks had no choice. Here's your touch screen. Here's how you're going to control the station. And he said it was really no problem. People took to it within half a shift, and they got it figured out. Even the more wizened among them. So yeah, we often assume that something will be a hurdle when in fact it may very well not be. And so far experience has been that it isn't a hurdle. So if you want to just kind of visualize better how this stuff lays out, the software is delivered as a software container. It itself is not pretty. It's command line stuff, and it runs on a computing platform in the cloud or on premises, as most people have done. And then to use it, whether it's a console or a phone system or whether it's an audio processor, typically these are browser based. So you just browse into the right port, the right IP address, the right port, and then you have control over it. Let's see, we already covered that. So when you get a traditional audio console, you already know exactly where you're going to install it. You know the furniture, where in the room it's going to be. You already know if it's going to have a separate power supply or redundant power supplies. We're used to dealing with the physical world like this. This happens to be K-Love's studios in Franklin, Tennessee. They're they've been in these studios for 2 or 3 years now, and they're eventually they're going to move pretty soon to a whole new building in Franklin, but this is where they are for right now. However, if you have a virtual mixing console, it's a bit different. Where's the hardware? Hint, it's not here. There's no on-air mixing hardware here. It's at the transmitter site. We'll take a closer look at this room later, but in this room there are several computers running the touch screens, but we're just using the browser. So they're honestly, there's some $200 computers running several of those screens. So where can you deploy virtual mixing infrastructure? Well, you can deploy it if you're not comfortable using your own server. You can buy an appliance from Telos or from other companies. Telos, we sell this thing called the AP3000. It's just a server motherboard, a server quality motherboard. And if you're an IT person and you bought this from Telos and you opened the box and you looked at it, you would not be very impressed. This kind of barely meets the qualifications of what you would call a server. But Telos knows all about this, and we sell it and we'll service it and we will configure it for you. Another possibility is provide your own server, and that's what I've done at my radio stations. I've provided my own refurbished, because I can't afford a new one, my own refurbished Dell servers. Another company called Broadcast Bionics makes something that they call VirtualRACK, and this is really cool. It's the more expensive solution here, but they deliver a piece of hardware, a server, that's got a front-end management wrapper on it. Basically, you browse into it, and it gives you an app store. And it's got products made by Telos, made by Sound 4 in France, and made by 2WCOM. And you choose the applications you want, whether it's a phone system or an audio processor or a bunch of codecs, and you click on them, and they literally install in a couple of minutes. And then you still have to license those products from their respective manufacturers. But Bionics has made this really easy. To go backwards a little bit, if you do your own bare metal server for these Docker containers, you also, if you get stuff from Telos, you also have to hire us to remotely install it for you, because it is not child's play. There's a number of things to set up which are not the least bit intuitive, even for people who have done a lot of Docker containers. If, in the case of Telos, if you buy that AP3000, we'll pre-configure it for you and then ship it to you. And if you need to make a change, we'll remotely make the change. Another option, this has become so popular that our dealer in Canada just decided to make their own little mini server. And so they made this little fanless platform called their XR1. PTS stands for Pippin Technical Service, which is our dealer in Canada. And they've shipped a whole lot of these. But they'll put Linux on this and make, Docker containers, or they'll put Windows on it and make Windows stuff if the things you need to run in Windows. Okay, let's see. I've already mentioned part of this already. We pre-install stuff on this particular appliance so that you plug it in. The IP address is already set to what you told us to, and it kind of just plugs in the rack like an appliance. Power and network, browse to the config pages, and then you configure it just like you would any other Axia console. This is Brian Jones, who's one of our really good support guy, to explain a little bit about how that process works.
AP3000 is a server class motherboard with the proper amount of computational horsepower to deploy up to 4 different containers. We have a menu, if you will. You could run, 2 Altuses and a Telos VX, or you could run a Forza processor, or 2 Forza processors and 2 Altuses, right? So there's combinations of things that we support on that AP3000, but at its core, the AP3000 is the computer that's sized appropriately for the options that we would sell it to you with.
All right, and here's VirtualRACK. I really already explained that. You click on the apps you want to install. They install very automatically. It automatically limits you to the number of things that will run on whichever size of server that you buy from them. And then, and here's to explain it. This is Grant Biebrick. He's the sales director at Pippin Technical.
I think the answer there is that we're being flexible with the deployment. Some people do have a big, robust data center, and they've got the dedicated IT staff that are able to manage that. And for those applications, yeah, we can put it in a data center. For a lot of our smaller broadcasters and the people that are taking the baby steps into virtualization, what they were looking at and looking for was something that they could just get in hand, put in the rack, plug in, almost like you used to do with a standard appliance. So for that, we came up with the PTS XR1. It's a fanless rack mountable 1RU unit that we pre-install the virtualized product on as part of the purchase price, and we ship it to them with their IP addresses. So it's really more of a plug and play solution.
So you may need some help deciding, hey, which is best, and not even shown on here is actually deploying it in a cloud environment in AWS, and that can be done too. Still, at the moment, the data cost for ingress and egress, 24/7 audio in and out, can add up to more than you may want to pay. But the actual hosting of the stuff in the cloud is not prohibitive at all. Here's an example of my station, Axia Altus, at the transmitter site. We determined early on that this was the best option for this particular station. And while no one is present at the transmitter site to operate the console locally, every day that morning show is done from the main studio. So you can, I want to run that again because it goes by pretty quickly. On the bottom left there with the red plugs is the Axia network. Then there are 4 refurbished servers there, one of which is an Altus console and the phone system also. There's a Nautel transmitter, HD, and then in the right-hand rack there were 3 automation systems plus a file server for those. That's all at the transmitter side, and it's a really good environment there. So here's Jeff McGinley to talk about that Jason Aldean restaurant installation.
So we have a cluster of stations in Knoxville, and we were approached by a restaurant group who was opening up a new restaurant in Gatlinburg, which is about an hour, a little bit more than an hour away from Knoxville. And they wanted us to do something similar. They have a studio and a restaurant that's in Nashville, and then one of our other competing, companies has a broadcast studio that they do for PM Drive Monday through Friday there. And since they wanted us to replicate that in Gatlinburg. So it took a little bit of time getting everything together, and I'm not going to get into the acoustics of the room that were also kind of hard to manage because it's floor to ceiling window, 2 feet away from the mics. But this was perfect. It was a perfect, Altus was the absolute perfect solution for this. So there are 2 stations that share that studio throughout the course of the week. So we did a bit of a LiveWire upgrade at the station and got a good LiveWire backbone going all throughout the studios, the TOC, everything like that. And we deployed the server at the station, and the DJs at the restaurant, they just connect to the server, and they use Altus for the PM Drive show. In the control rooms in Knoxville, we also deployed giant touchscreens for their consoles. So they're using Altus both in the station and out at the restaurant.
Okay. Here's a photo of the remote access to the Altus console. And so this is the studio at Aldean's Kitchen and Rooftop Bar in Gatlinburg. Because Altus offers that WebRTC option, they can securely connect to Altus over a regular internet connection for monitoring and for contribution audio. This means they can operate anywhere that there's an internet connection, even wireless or a 5G mobile connection. You can think about having permanent remote studios like in nightclubs or churches, restaurant or bar, other remote outside broadcasts. So lots of possibilities show up when you do this. You can even do a live broadcast from an SBE meeting, as I've done. Here's Jeff again to talk about some of the technicalities of the different sources and audio routing.
Deployed a Telos VX, and it's just coming up on a fader, and then we're using the X-Screen software that's basically dialing in, and that's selecting a line. And because of the mix minus, if they're out at the restaurant, it actually operates the exact same no matter whether or not they are in the studio or without. All the audio comes up in one fader They're able to select the call, and once again, the caller has no idea whether or not they're in the studio or at the restaurant. Sounds flawless.
Jeff was referring to some software from Broadcast Bionics. They could, but they don't use the phone button controls on the Altus console. They use some third-party software, which also gives them easy call screening, so they can call screen from the studio in Knoxville or from Jason Aldean's kitchen in Gatlinburg. So that they just prefer to use the third-party software. This is Ryan Pratt. He's the IT director for a group of radio stations based in Toronto. He credits their Axia Altus virtual consoles for allowing a style of work flexibility that previously they couldn't have.
So we have three studios, but we have 4 Altus consoles. So one of the consoles that stays as our on-air console isn't actually in a studio. Using Pathfinder, we switch at any given time which studio is accessing or being on the on-air studio. So this was one key feature that we needed, because we were in a smaller space, that we have one large studio and 2 smaller studios. So when we have more on-air guests come in, we move that studio to be the on-air studio using Altus. And when they're done and we need it for production, we move the on-air to a different studio.
Here's Jeff talking about up to 8 people can use the console at the same time.
So if they're at the restaurant, there's no one in the control room back at the station.
If you want to have a 2-location show, Altus does that perfectly well.
Oh, you could do even more locations than 2. With the WebRTC client, each location would just come up as a different source on a different fader, and they would all have a mix minus and could do a show in multiple locations all at the same time.
This is Tyler Everett. I want to introduce you to this guy. He's the president and CEO at our dealer in Canada. They do a lot of installations. They sell equipment, but they also design studios and build studios. They're kind of a full-service integrator. And he says that Altus makes it easy to bring in talent from other locations.
And not only that, you can have a multiple person show, say a co-host and a host in 2 different areas, for a show in a 3rd different area. So everybody can do everything from anywhere. And that's really the strength of the system, is that it allows radio companies to leverage their resources, as they would say, to be able to make the fullest use of them in any place. It also is great if you're maybe syndicating a show, you want to do a special on say a rock station, and you want to cover all your rock stations across your chain. You can do that from one place, but it doesn't have to be necessarily the announcer in the studio you're doing it from. He could be in a studio on the West Coast, and the show could be originating from the East Coast, or any combination. So there's just so many different ways of doing things. And that's really what gives the power and the flexibility to a virtual solution.
So here's a little bit more about how this can lay out. The notion of operating a broadcast studio from anywhere deserves consideration and perhaps some creative imagination. With nothing more than a computer, tablet, or a laptop and an internet connection, and maybe a good microphone, you can fully control an Axia broadcast audio mixer. You get real-time graphics, control, real-time control. Anybody who's participating can turn their own mic up and down or fix something. So this is what it would look like. Here's that KZOZ morning show. So this notion allows doing the show, having talent in other offices or studios that are on premise, but also do it from off premise, like homes or even hospital beds. If your boss really makes you work all the time, a hotel room, churches, sports venues, or from Jeremy's kitchen. This is the guy that had to move. Jeremy's kitchen. Let's skip here and hear one more from Chris Green. Again, this guy's not real technical, but he's fun to listen to.
Everything's touch. It does absolutely everything you might ever imagine. The automation system's running out of here, everything in program. My hotkeys come out of this one right here, which is super convenient. And now I can manually trigger all the hotkeys too, with all of these colorful buttons in this area. It's just a treasure trove of buttons and fun. And then when I'm in the production room, I can engage my mic over here as well. Boom. and my guest mics. It's just awesome.
So what he was showing you there, I'll explain each item. Of course, the left-hand most computer screen, that's a Dell 24-inch touchscreen, costs about $325. And then strapped to the back of that is a little NUC style, computer. It's about $220. I chose that one because it had two built-in network interfaces, and one of them goes to our business network for the remote access. The other one is dedicated to the Axia network because in that browser, and it's full screened right here so you can't see it, but there's another tab open, and that tab has the WebRTC access to the transmitter site going on right now as this picture is taken. So there's actually two tabs that Chris Green uses every morning. He typically closes the browser when he leaves in the afternoon, comes back in, opens it fresh, and there's a bookmark bar. He clicks literally one button and enters a password, and he's in on the console, and then he full screens it. But before he full screens it, he opens another tab and he clicks, and then he is connected with the WebRTC. So then that's his contribution audio. The next screen over is another NUC computer strapped to the back of that monitor. It's just running a remote access, a remote desktop program. I happen to use one called dwservice.net, and but it's just remoted into the automation system at the transmitter site, the automation that he uses. There's also a little app that he can bring up on that remote computer that switches his audio routing. This station doesn't really need the services of our Pathfinder software, so I use a little free program called the Livewire Simple Delegation Switcher, and I've made a little button panel. He can switch what's on the air. He can put the console on the air. He can put the automation directly on the air, or he can put the other automations on the air, since there are three of them at the transmitter site, including the backup. There's a backup automation as well. The third screen is another Dell touchscreen, but it's connected to a local computer there in the room. It's just a refurbished Dell desktop. It's down in the rack to the right. And it's running a browser, but the browser is browsed into a little product that Telos is still selling, although we may not much longer. It's called the IQS. It's just a little mixer. It's a lot like the Axia Altus we've been talking about, but the IQS does not have WebRTC capability, and it won't. It's kind of meant for a virtualized local mixing solution. But that's what he uses for his production. That the yellow screen that says OMG on it, that is a second monitor on that same computer. And it's what he does his multi-track editing on when he's producing commercials. So that mixer there locally, that IQS mixer, it mixes the local mics together. We only want to send one feed to the transmitter site for our contribution audio. So we want to pre-mix the mics together. If we sent them separately and you listen separately, you'd have delay, and you'd also have the local audio with no delay, and that would be weird. Trust me, that doesn't work. So we list the talent in the room hears each other with no delay, and then it goes on the air with probably about a 6 millisecond delay going on there. Not bad. Okay, so that's the control room and the functionalities there. I'm going to spend a couple minutes on virtualizing something else, that is audio processing. You may be familiar with the Omnia 11 or the Omnia 9. Well, now we have a couple of virtualized audio processors. The one on the top right there is called Forza. It is also a containerized software, so it runs in a Linux environment. There's a version of Forza for streaming audio, for HD, for anything that's a bit rate reduced transmission path. And then there's the Omnia Enterprise 9S, and that is the software version of the Omnia 9. And it runs in a Windows environment. So you can run it in the cloud, but you have to run Windows in the cloud, which you can do. You just got to pay for it. Or you can run it, locally. It actually is extremely efficient. We've got people who have literally run 64 of these on a server. And so that's pretty efficient to program and it's the full Omnia 9. It's everything that an Omnia 9 can do, including putting out micro MPX. So you can process on a Windows machine and put out an IP stream that would go to a transmitter site and get decoded by a micro MPX decoder and give you composite baseband. So those are all possibilities. One thing I want to get an answer to is, okay, how do we find virtual audio processing? Because for over 10 years now, we've been doing processing that doesn't use, transistors and gain functions in hardware. How do you define what is virtualized?
Well, when we as Telos Alliance talk about virtualization, what we're really talking about is taking proprietary hardware out of the equation. So in the case of Omnia Enterprise 9S, we have a product called Omnia 9 that has hardware. It has built-in front panel with a screen, power supplies, proprietary I/O, all built into the back of the hardware of the appliance. So when we talk about a virtualized version of this, it's all of the same processing, all of the same software, all of the same sonic capabilities of that hardware product, but without the hardware.
Okay, I guess that makes sense. So virtualized audio processing, I just want to point out, it's actually becoming quite mainstream. There are literally hundreds and hundreds and hundreds of channels, both online streaming and FM channels that are being processed virtually. So anyway, I'm not going to, I do want to point this out, that hardware versus software, it's an interesting dilemma that some people are having to face right now. And we want to point out that it's a choice. Software is not a challenger to hardware. Some broadcasters want or need hardware, and we still offer all the physical gear that you're looking for that way. Some broadcasters are deploying software because it's efficient and highly scalable. Of course, if you only need one, you don't need scale. So, maybe software doesn't make as much sense for you if you only need one or two of something. You can choose what's right for you and your facility, because we plan to keep on making that. Here's Marty Sachs talking about broadcasters using or choosing virtualized options.
One example is a large national broadcaster here in North America that has hundreds of our virtual Omnia processors powering their channels. They installed this system a number of years ago in a new radio and television facility. It's all IP. And they're getting ready to build another such facility because that first facility was such a success. Truly, this is not the right solution for some. And that's the reason why we will continue to produce our Omnia processing in hardware format for years to come.
All right. In interest of time, I want to move ahead here. I'm showing you how you might deploy virtualized audio processing. So let's say here's your program source, whether it's a studio or the output of an automation or that's switchable. And here's your transmitter site. Maybe you'll do what I've done at several of my transmitter sites, not all of them, put in an MPX decoder node. This is the Omnia MPX decoder. So you have IP coming in at roughly 500 to 800 kilobits per second, and that has the micro MPX data, and what comes out of it is the analog composite or MPX signal. You could process using an on-premises server. You would feed audio into that using LiveWire or AES67. And then coming out of that on-premises server, you would use micro MPX. Another possibility is an appliance approach like the AP3000 we looked at earlier. And yet another approach would be to do it in the cloud at Amazon Web Services. We did a big experiment with Nautel a few years ago just to see about the resiliency and automatic failover that could be available doing this in the cloud. And we actually instantiated this in 4 different Amazon Web Services data centers, and one by one we killed them until we were down to 1 in Brazil, and the station never missed a beat. It kept on broadcasting. So the switchovers were seamless. And all that's controlled just typically by a browser. The Omnia 9 software is controlled by by a Windows client, but everything else is controlled with browsers. Here's Frank. Everybody likes to hear from Frank Foti, so let's hear from Frank about this notion of virtual processing.
Well, Kirk, there's a couple things going on here. First, this is the initial step from Omnia of putting something into the cloud-based, software. Well, I feel funny saying software because we've been doing software since, Omnia FM came about, it's software. But this is our first step where the actual software is going to reside on a different platform, and that being in the cloud on a server or something of that nature. Something that is a topic that's been internal discussion within the Telos Alliance for a few years, but it's something that we as an organization must support. And that is in some ways serving two masters, that being, and I'm going to call the platforms the master. On one hand, one platform being hardware, we're going to support and serve that for a while yet. And then the whole area where, it's audio, software as a service or on a server in the cloud or what have you, that's a different platform. And that's an area that in the world of broadcasting, we're at the front end of the bell curve. We've come across, some large broadcasters that want to be there and they're doing this, but the same token, there's, the customer that comes up or reaches out and says, hey, my comfort is knowing that there's a physical box in my rack. We have to support them too.
When you move to software, you can financially do an optional deal. You can do CapEx. You can pay somebody for the software, or you can make it a monthly expense or an annual expense using operating expenditure. It's up to you. I know sometimes we don't like companies that don't give us a choice, like some people have been, have to pay for Adobe products monthly, even if they want to buy them out. They can't. But so far, at least for us, you can do that either way. There's a few other products I didn't talk about, but a company in Germany called Younger. We do extensive work with Younger. We don't own Younger, but they're a very popular company. And we're kind of the exclusive agent that works with them. They make a virtualized audio processing product called Flex AI. And then if you have file-based stuff to process, whether it's TV shows, feature-length films, or commercials or podcasts, we have Omnia Tools and Audio Tools Server. These are a couple things that typically you'd have a watch folder and you'd throw your files into a watch folder and then it'll process them all kinds of ways, whatever you set up, even for just compliance purposes. So you always get a certain level, output level in DBFS. You can have that, or LUFS, LUFS. So, virtual mixing, and let's see. Oh, I wanted to show you a little quick video here. It's a minute long, and I was just really impressed by this. It's part of a TED Talk. The company here is called IO, and this is Jason Rugolo, who is the founder and CEO. Just give this a watch and a listen for 1 minute, and you'll be kind of impressed at kind of where the world is going to. And everything he's showing you here is real. This wasn't made up with post-production or any trickery. This was actually happening with the product that he's showing.
So imagine that you're sitting in a noisy restaurant and you're having trouble hearing your friends across the table. Hey, can you enhance the sounds that are right in front of me? And can you turn that baby down? That's better. And I'm still having a little trouble hearing Pedro. Can you isolate Pedro for me? That's perfect. And my Spanish is a little rusty. Can I hear Pedro but in English?
And at the end of the trip, we came back to the city to visit the historic center.
Michelle, close all programs. Oh, it's so much worse. Okay. It's pretty cool, right? It's pretty cool.
So I've been trying to think about, are there ways that we could use this like for remote reporting or telephone voice processing or things like that, so you could really isolate how somebody sounds. I use Apple's Final Cut Pro video editing software, and sometimes I get, well, on all the video interviews that you saw during this presentation, I used the voice isolation. So if they're talking to me from a crappy location, or their microphone is 8 feet away from them, or they're sitting on it, this cleans up quite a bit. Hey, we're done, except I wanted to pass along a couple things that I've discovered in the last 2 or 3 years that just as an engineer, maybe you'll find them helpful as well if you don't know about them. For remote access that is either free or you're welcome to make a donation. I think they're actually selling levels of service now, but so much cheaper than TeamViewer or some of the other applications out there. I've been using dwservice.net for a long time, and I really like it. I do send them a donation of $6 a month. But anyway, I have over 100 computers that I remote access with DW Service. And it works, of course, with all the major platforms. For SIP telephony, I'm involved with a lot of phone calls with customers of Telos who are buying their first SIP phone system, or their first one for the control room, or for on air anyway. And they're having trouble really getting a dialogue going with their local phone company or whoever they've been dealing with. There's 100 or more SIP providers that would like to sell you service, but a lot of them are set up to sell services to a dentist office or a law firm. They don't really understand broadcast very well. This company, ClearlyIP.com, the guy that's the CEO of Clearly IP, he's the guy that actually, I won't say he wrote Free PBX because that's based on Asterisk, but he put together a team of developers that did come up with Free PBX, which is the free open source SIP PBX program. So he gets it. He understands broadcast. I even did a Twort episode with him. Tony Lewis is his name, but Clearly IP will sell you SIP trunks. They'll do cloud hosting of a SIP PBX if you want. And all of my stations use Clearly IP. One thing about VPNs, a lot of people talk about instantiating a VPN, and one problem with VPNs is that if you give somebody remote VPN access, if you don't know exactly what you're doing, and I don't, they have access to everything on your network remotely, and that may not be what you want. Now, I know there's ways to restrict that, but one way to restrict that is instead of using a VPN, use something called Secure Tunnel. And Cloudflare and other companies are offering Secure Tunnel. I have one coming into my office here, basically, and so remotely I can access it, but it only gives me access to the devices that I want. You can try all this stuff out for free. Cloudflare is one of the companies. I wouldn't say it's easy to set up. I had to watch a couple different videos on YouTube, step by step, how to set it up, but it did work well. A lot of people look for some way to display computer information in real time on their screen. And BG Info is popular, but I don't know, I kind of don't like it very much. So I found one called Sidebar Diagnostics, and I really do like this one. It's free. It's available on GitHub. And if I can install it, you probably can too. So yeah, Sidebar Diagnostics is the name of it on GitHub. I know I've talked about MPX over IP. Micro MPX is one of the ways to do this. It's the lowest bitrate method of doing this, and it's pretty amazing. And you might think, well, yeah, but does it sound bad crunched down to a lower bitrate? No, it doesn't, because it does not use a psychoacoustic algorithm. It uses pure math. And interestingly, the math that they use is pretty old-fashioned math. It makes noise, but the noise is all in parts of the spectrum that are filtered out. So what you end up getting is a very clean signal to put into your FM transmitter. Okay. Anyway, I did just my vote goes for Micro MPX. It's really cool. If you're doing audio over IP and you haven't already looked into a CBS 350 series of Ethernet switches, these do work. They're not quite as robust as the real expensive Cisco switches, but they're also typically all well under $1,000. So I've been using these CBS 350 switches quite a bit. And finally, I'm liking multi-ping software. Multi-ping, here's a graph, lets me monitor lots of different sites, both studios and transmitters. And all it does is ping all these sites and show you graphs of the ping over time. This is these are all 12-hour graphs right here. But just knowing the ping time and graphing that over time can tell you interesting things about the quality of the connection. Obviously, the red means missed ping returns. If you're pinging some place that's on fiber and you're on fiber, you should have no or practically no missed pings. But yeah, the big red block is a transmitter site that's fed by a wireless ISP that is pretty unreliable. And then the top right one, where the time changes, the time of the ping return changes, that's a 5G gateway. So when people start computing in the neighborhood, then the ping time goes up. And that's it. Certainly available for some questions, or available for everybody to go to lunch, whichever you prefer.
What was that last one, Kirk?
Last one.
The last software you're showing there, that one?
It's called Multiping. It is a paid-for program. I think I paid $40 for it, and I may have paid a maintenance fee for some updates, but Multiping is the name of it.
Cool, thank you.
I don't find it the friendliest thing to set up. It probably took me 2 hours to set up that graphical, all these different places, in a but it tends to start if I close the computer, it tends to start back up with what I spent so much time setting up.
Very cool. Hey, Austin, why don't you ask your question you have in the chat?
Oh, I didn't check the chat. Sorry.
Well, there's one question only.
Well, okay. Yeah, I was just curious. I was curious about how FCC regulations are keeping up with all this new technology, especially with respect to studio locations. What kind of limitations are there based on regulations? And
so for a few years now, there's been no more main studio requirement. You used to have a main studio either in your city of license or within your coverage contour, your main coverage contour. That is no longer required. Also, your public file used to have to be maintained in your city of license. And for people who move their studio out of the city of license, they typically maintained it at an attorney's office or at the public library or something like that. But now the public files are all online. And so the FCC has instant access to them all the time, and so do you. So that's not a requirement anymore. So you don't have to have a studio in your city of license, or even in the area. You can totally program something separately. For EAS, the rules still are that you. I don't know how to say this with full knowledge. I will say that. The transmitter site that I showed you with those two equipment racks, our EAS gear is right there in those racks, and it will interrupt. It's set to interrupt even if we're not there. If obviously we're not there, even if we're doing a live show, it's the last thing in the chain, and it will automatically interrupt. The big question, I think, is broadcasters like K-Love, EMF, or other broadcasters, iHeart and others, who are operating more and more stations where they don't have a local presence. They still have to, according to the rules, still have to have local EAS gear. Personally, I think that we have the technology to just as well do this remotely. And I know the people at Digital Alert Systems, DAS, and Nautel and Telos have been working together to make this a little bit easier, but you still have to meet the requirements. And my understanding is you still have to receive stations over the air. I'd love to see a company like EMF, K-Love, or iHeart, or Odyssey, or Cumulus say, hey, FCC, we'd like to centralize our EAS operations. We'd like to monitor our assignments over the web instead of over the air. And making sure that they have EAS alerting in their web stream. Maybe we get a private web stream. Maybe they just do it post EAS, and we'll monitor them that way. And then we can still interrupt our programming. To me, and I realize there's problems with that too, but there's also problems with the way we do it now. What if you're at a transmitter site and you've got all this blanketing interference and your EAS box can't properly pick up your assigned station that maybe is 40 miles away? So, there's difficulties there too. So, and the more we get into the CAP server, we get much better audio that way, although the National Weather Service is still not on that. So it's a good question. I think we're in a very uncomfortable time of limbo where we could be doing a better job or a technically more interesting job. And there's people who will always argue for, yes, we monitor over the air because that's the most reliable way. Well, go check all the hurricane stations that are off the air. They're not transmitting any EAS messages. So.
Any other questions?
Hey, thank you.
I do.
Yeah, Todd.
Well, you can set up a remote station essentially with a mixer, and let's say you have a USB mic going into like an MV7 going into the computer, transmit and work from, say, if you had to work from home. What would like if Axia is UDP, audio over IP, how is the audio being transmitted? Is it like Zip1, or do you need a more robust internet connection?
Gotcha.
What
Okay.
kind of connection do you need?
So if you're using a browser, like we showed you with the console faders on the screen, and in a separate tab, I had open the WebRTC connection, which is also available. And when you, at least with our product, I don't know how other companies are going to do this, but with our product, when you buy Axia Altus, you get a 4-fader mixer, and then you pay some more money, you get an 8-fader mixer. You pay some more money, you get a 12-fader mixer. And then you pay some more money and you get different choices for the WebRTC connectivity. So, you can buy just monitoring. So let's say you've got a slew of people out there from home. They're going to run basketball games during the March Madness, right? They don't need to talk. They just need to listen and play spots at the right times. You can pay a minimal amount of money, and they will just be monitoring through that WebRTC connection, which, by the way, can be a low bit. It can be as low as 32 kilobits, or it could be up to 384 or 500 kilobits. So that is coded audio, just like you and I are talking right now. So that's the bandwidth for the remote listening and the remote contribution. But it's now it's psychoacoustically coded. You wouldn't want to code it over and over and over again. But for one pass on one trip, nobody in Oxford, Mississippi knows that our guy is talking through a browser codec, right? He sounds great on the air. He sounds fine.
Is this like the Opus codec that's in the browser?
Yes, that's exactly what it is. Yeah. WebRTC is the Google invented wrapper and communication protocol. It includes all the things to get through firewalls. If you go to a website that uses WebRTC, I was shocked. It's kind of complicated. There's several moving parts, especially with regard to stun and turn servers, and you can hire those out third party. They exist on the web. You can hire somebody's stun and turn server for pennies, or you can have Telos install it on the same machine where Axia Altus is. Or if you're an iHeart, maybe you just run a server farm with lots of stun and turn servers that different people have access to for different shows. I don't know how different people handle it. At mine, the stun and turn servers run in their own Docker containers on the same physical hardware as the audio console and the phone system. And I didn't install any of that stuff. The smart guys at Telos Support did.
Okay.
And it was a year ago. It was early days, and they had a script to install everything. And well, that was early days. So they installed it with the script and realized there are still things that didn't happen automatically, and they had to go in and fix a few things. But anyway, within a few days, it was all working great.
I had a slightly off-topic question for you. Do you know of what a Docker solution to keep these different streams in time with each other? Like if you had like 3 different like Opus streams ingesting, and I wanted to keep the packets in time with each other. Do you know of a solution?
I don't. You'd think there'd be some. So that sounds like a solution that would involve, and maybe I'm using the wrong words here, but would involve a transport stream that would collect these different things that you want to keep bound together, and they would all have to travel together in some kind of a transport stream. And if I'm not, again, happy to be corrected if anybody knows better, but when you watch IP television or receive TV over satellite, these are going through transport streams to keep the video and the audio together. If you have separate streams going out, they're certainly at a minimum, those are subject to slipping within at least one packet of each other, and one packet is typically going to be I want to say about 1/200th of a second. It can vary depending on the bit rate of what you're sending, or maybe as little as or maybe as much as 1/50th of a second, and it could slip, and then that's at the minimum. It could slip by 2 or 3 or 4 packets. I know that with technologies like with Telos stuff and other codecs like this, like Comrex has something they call crosslock, I believe. And there's other companies have their own solutions where they might send out the same packet twice, perhaps over 2 different networks. And when they come together at the receive end, each of these packets is numbered, and they have the same numbering. And if the receiver says, "Oh, I've already received this packet number," and it just tosses the redundant one. But let's say it never gets the one it usually is getting from the first stream, but it grabs it from the second stream. That's a real typical error correction method, although it does double the bandwidth. And there's been all kinds of ways to try to correct internet errors, including just sending the stream twice, but 3 seconds apart, and putting the buffer at the receive end to be at least 3 seconds. And then if most internet problems may be bursty in nature. So there's lots of different schemes to overcome different types of transmission losses. MicroMPX has built-in forward error correction. So you add a certain amount of packet data. So you might end up close to doubling your bandwidth, but forward error correction can typically solve missed packets over a wider span. And I've got a friend who programs a Christian radio station in, I believe, North Carolina, and he sends it to the island of Grenada. And there's packet loss, but you don't hear that on the air because I dialed in some forward error correction in the MicroMPX transmission algorithm. And now if he has no internet, he has no audio, but let's see, would RTP or RIST help with synchronization? Well, RTP is just real-time protocol, so that on its own, I don't believe has any mitigations. RIST I'm not familiar with, but there is SRT, Secure Reliable Transport, and Telos is building this into some of our products because EMF K-Love is going to be distributing to some of their transmitter sites via Starlink. And Starlink has a lot of dropouts that are upwards of a second long. And so they don't want any dropouts on the air. They have some dropouts that on Starlink, their testing shows the upwards of 8 or 9 seconds long occasionally. So they're going to have enough diversity in their streams to handle that.
Great. Any other questions? This was a great presentation, Kirk, and I appreciate those tips at the very end.
Well, thanks. I've enjoyed putting them to use as well. So if I can find something to share, I'm happy to do so.
Fantastic.